Well, good morning, everybody, and I think we'll look to start. My name is Catherine Megan. I'm the Assistant Director of the RAI, and I'd like to welcome you all to the third CITA workshop for 2013. This is the second year that they've been running these extremely successful workshops. You're all very welcome, and I'd also like to welcome the growing numbers that are watching these workshops online. I believe that the numbers watching online are now exceeding those attending, which is great, and we hope those numbers continue to grow, so they're all very welcome. As most of you will know, this meeting is part of a series of workshops that are considering the various project stages from pre-design project planning through construction and post-construction facilities management. The objective is to understand the technology tools and work processes that will facilitate better collaboration between project stakeholders and promote better integration for overall project delivery. Today we are looking at detailed design stage and considering how various technologies for architectural and engineering design can streamline workflows and reduce duplication of effort and reduction of coordination problems that lead to cost and time overruns. The RAI is very pleased to be hosting this particular workshop. We are founding members of CITA, and the RAI fully supports the adoption of new and better ways of working with the aim of improving better quality and more competitive services. The Institute of Architects is particularly interested in the message that has been delivered today by David Miller Architects as an SME practice that has leveraged BIM to improve their business offering and grow their practice in difficult times, and believe it, we will be led to believe grow their turnover as well, which is a great achievement in the last couple of years. The RAI is also aware that there's been a great deal of work done in providing education to all sectors of the industry in how to implement BIM into their offices. But we're very keen to hear from David as well as the why to and the business case for using BIM in construction offices. For those who don't know David, I'll just give you a short background on him. David has been working at the highest levels of design in both the UK and abroad, and is passionate about progressive architecture, emerging technologies, design and delivery excellence. Prior to establishing his own practice in 2000, he was Associate Director of Future Systems and Project Architect for the Sterling Prize-winning NatWest Media Centre. This project allowed him to develop his interest in the refinement of form through 3D problem solving, which he had gained in Santiago Calatrava's office in the mid-90s. His specialist knowledge of the design and delivery of complex buildings has evolved an interest in dimensional analysis and modelling using computer as a creative tool in search of delight and proportion, which is fundamental to the approach of his practice today. After David's keynote address, we will be having a workshop, which is been the form of these events in the past, and we'll give you details of that after David's talk. So I'd now like to welcome David to the podium. Thank you.
Just bear with me a second. Right. Okay. I thought the best way to approach this was to describe our BIM workflow and how we're using BIM tools in an everyday environment to solve everyday problems in a small practice. So to give you a little bit of a view of where we're coming from, we're a small practice in central London. We have actually grown from 4 to 14 in the last 4 years. And our workload is very typical of a small practice, being affordable housing, schools, student housing, budget hotels and mixed-use development. So it's a very, very normal practice doing very normal work. As Catherine said, my personal background was complex three-dimensional buildings. So we were always going to be looking for a 3D solution to our production information needs and this is back in 2008. So 2008, when we were 4 people, we did convert the whole office to effectively what turned out to be BIM tools, but really for us we were looking for this 3D solution to our workflow. And we found that very quickly we were getting very real advantages from that and got much more engaged with it. We were finding that we were able to build our quality system in the office around the tools, and that's evolved over the last few years. And we found that using the tools really increased the motivation of the people in the office. So it created a real buzz in the office and gave us a real, it felt like it gave us a real edge. For the talk, I based much of it around one particular project, though I do go off-piste every now and then because the talk's evolved a little bit. The vehicle for the presentation really is this primary school in Westminster. It's George Eliot Primary School in St John's Wood. It's got a construction value of £9.5 million, and it was completed at Christmas. And this is the federated model of the structure, architecture and M&E for that project. For the talk, I wanted to look at it from 3 points of view. First of all, how we as architects are getting advantages from using the tools. Then look at the implications that we've found within the design team and how it's changed the dynamic within the design team. And also just briefly look at how stakeholders have started to engage much more with the project throughout its life cycle as a consequence of using BIM tools. So as architects, we're finding that we're using the tools on all projects right from the very beginning now. So even at a feasibility stage, when we're massing up a project, we're getting real-time areas, volumes, and now real-time costs, broad brush costs at the beginning of the project. And we've been working with our contractor clients to refine this part of the process. So what we're doing is getting the opportunity to value engineer right at the beginning rather than value engineer at stage C, where effectively we're going back to the drawing board when things start to overrun in terms of cost. One of the other things that we've been doing, and we're now using this on all projects, and developed a strategic alliance with our supplier for this, is we're placing all of our projects in three-dimensional environments created through photogrammetry. So we're able to get a three-dimensional model of our sites very, very quickly indeed, within a few days, for a few £100. And these models are accurate to 40 centimetres. So for an early stage feasibility, we're able to mass up the project at really early stages in a pretty accurate representation of the real environment. Bearing in mind that quite a lot of these feasibilities in the past we would have done using OS maps, this information is actually more accurate than Ordnance Survey. And it's going a step further as well as the amount of data around is increasing. Here there's a project, the yellow building in the centre is the project that we're working on. It's just got planning permission. It's a hotel. What's interesting in the environment that we're modelling it up in is the pink buildings don't exist yet, but they've got planning permission. So we're able to mass up the building in its future environment as well as its existing environment, which is giving us a real advantage. And this really is the key slide to explain how we're seeing the workflow at an everyday level. So the four projects here are four schools in central London, three in Westminster, one in Tower Hamlets. They're all on difficult urban sites. A few of them are in conservation areas. One of them's got a listed building attached to it, and they're all tight urban sites. So clearly, all four projects are completely different and have to respond to different urban needs. But they're all in fact made out of exactly the same components. They've got the same windows, the same doors, the same structural systems, the same roofing systems. So effectively, they're the same kit of parts but reassembled. Each of those projects is a BIM project, and as we've gone from project to project, we've been able to refine our library of components and build up the data that we've got on those components. And in effect, the fifth school, so to speak, we would effectively we're able to blow that set of information apart and reassemble it very quickly indeed. And this slide was actually used in a pitch to get another school, which was this one, which is actually a refurbishment of an existing building. It's it's an adult education centre built in a large 70s building, again in Westminster. The key thing for us here is this project took 1 year from the first conversation to being handed over. Again, this was handed over at Christmas. That included a planning permission and quite a detailed insertion of new stair tower, lift core, that sort of thing. And I don't think it would have been possible if we didn't already have all of the information in our library so that we could assemble it very quickly indeed. At the early stages now, we're also able to attach quite detailed information to very simple geometric representations. So these quite simple blocks are representing different components within the social housing scheme, but in effect all of the housing quality indicators are attached to each of those blocks. So we're able to mass up a proposal very quickly and actually get quite useful data out of it at a very early stage, which again is allowing us to do very quick feasibility studies and give our clients very much more accurate, much more useful information at an early stage. While we're still establishing feasibility. Clearly this is only the start. It needs to be finessed and made beautiful, but it's a really good way of getting going. And rather than starting from a blank piece of paper each time, being able to start from a data set that you've already established and refined in the past is a great advantage, and I think a real change to how the workflow within practice is going to develop. And again, there's lots of tools becoming available to us that are allowing us to do things that in the past we would have to go out to a specialist to do. Quite often the budget wouldn't exist to do that, so it might not happen. So being able to use these tools is allowing us, especially as those models exist from the very beginning, to start to get things pretty well right at an early stage. Again, avoiding that situation where you get to a stage C report and there's too much glass in the south facade and you're looking at redesigning. And similarly, these tools are giving us opportunities to do a very affordable interventions. This is actually a very high-level model of a Victorian school, again in Westminster, where there was an overheating problem. It's an old Victorian school. And the budget for the whole project, including fees and the construction of the solar shading, is about £10,000. So clearly there's not going to be any budget there for expensive consultant input. But being able to use the tools that are now available to us effectively free with the softwares that we're using, we're able to get a pretty good idea of how to deal with the solar shading ourselves. And again, offer the client something that they wouldn't normally get. And this is really a representation of the same sort of thing. We're working at an accuracy, I believe, of about 20% of plus or minus 20% of what we would be getting if we were doing we were paying a consultant to do a high-level thermal model. But at an early stage, when you're establishing feasibility, this is perfectly adequate to get it pretty well right. And really, for us, this has been the big change in terms of how our team are working. They're now effectively working in a single environment throughout the process. There's only the specification where they're coming out of the model, though we're working towards having the specification in the model now as well with the new developments from MBS. And the great thing for us is effectively the team are assembling the project rather than sort of drawing diagrams of it. I think that's the key change in terms of how they're working. Similarly, very usefully, nothing's wasted and everything's available and retraceable, so we're able to go back at any stage of the project. And in the past, what we would have been doing is effectively redrawing at each stage and wasting lots of effort moving backwards and forwards from 3D software to 2D software. So prior to starting to work like this, we were modelling all of our projects in 3 dimensions, but using other software, and then reverse engineering it into 2D drawn information. So clearly being able to work in this way where we're in a single environment is much more useful. So it's in improving our efficiency and improving our quality control. As the team are always in the model, there's lots of eyes looking at it. And the models really become the centre of all the activities. And so having this virtual prototype can only be a good thing. And as I'm sure lots of people are already very aware of this, but it's very intuitive, it's very easy to use. The library is quality controlled. If we're working with a particular client, we can pre-select the library so that we know that we're doing things that they're happy with. So here again, just another view, a view into the same model, but a more conventional view, a view that we're more used to seeing. We're finding with using the work sharing tools as well that we can have teams of up to we've worked with teams of up to 4 people in one model at any one time. It takes a little bit of organisation, but it's nothing that's too difficult to do. The next couple of slides really are to explain how we're dealing, how we've been dealing with level of detail. So this is level of detail at stage E. So we're at this point we're still monitoring areas, so that we've got a live link to schedules for the areas within the project. There's still a possibility that walls might move around. We're actually currently looking at a red light, green light part of this as well, so we can compare the areas to the brief. And at this stage, the model, the components within the model know what their performance criteria are, but they don't know what they're made out of. So a partition might know that it's a 43 dB partition, or a door might know that it's a half-hour fire door, but it doesn't know what it is yet. Once we're into production information, we start to swap that information out for very real information. So by this point, the wall will know how many layers of plasterboard it's got on it, whether it's Lafarge or British gypsum. The doors are starting to be replaced with actual products. So it's that getting that level of detail and building that level of detail up throughout the project's really an important thing to get right. In terms of detail, we're dealing with detail in 2 different ways. We've got 2-dimensional detail within the model, and we've got 3-dimensional detail within the model. So this is one of the 3-dimensional details, and effectively, when we bring a piece of curtain walling or a window into the model, it's bringing the closing details, the EPDM detail, and the splay on the concrete with it. So what's been quite interesting here is the contractor's been procuring the shutter boxes for the concrete using the architectural drawings. So even though the architectural and the structural drawings, structural information is coordinated, we're absolutely sure that the splays on the concrete are correct within the architectural information, because that's what we're procuring the windows from. But we also have 2-dimensional information within the model, and that's really just to keep the weight of the model down to a handleable size. So on a project like this particular school, the model can get up to about 200 megabytes, excluding things like furniture and FF&E. There's a separate model for that. So things like fireproofing details are scheduled throughout the project, but are effectively drawn in 2D, but it's still within the same file. And we found that it's been really useful to be able to put in little 3-dimensional representations on the working drawings to help describe what's going on. And there's actually quite a nice anecdote with the handrails in the school. Because it's a primary school, there was 2 handrails. On the early drawings, the takeoff for the handrails missed the second handrail because they were all, obviously in the 2D drawings, they were drawn on top of each other. It just wasn't read by the contractor. Obviously, with the 3D representation, that problem's overcome. And here we're looking at, say, at the window that's highlighted in blue and the data that we would have on that window at this particular point in time. And obviously, what's nice is we can edit that within the library, we can edit that within the software, and a change anywhere is a change everywhere, which is very good for our quality control. And as an architect, one of the greatest things is, of course, that the schedules are for free. We're no longer spending weeks doing door and window schedules. And again, because this information is, because the parametric change engine within the software allows a change anywhere to go right the way through the project, and this information is all searchable in a very, can be ordered in a very conventional way. We had a particular situation with the project where we met with the secure by design officer, and he required all of the ground floor window, all the glass on all of the ground floor windows to be laminated, and it hadn't been up to that point. So we're simply able to search for or order the spreadsheet to highlight all of the ground floor windows, make the change in the schedule, and that changed the representation right the way through the whole project. Now, previously, we would have had to go through each instance all the way through. That might have taken a day and a half, cost £1,500, and there's a good chance we might have missed one, which would cost even more. Here, it's very, very quick, very, very easy to do. So it's allowing us to make changes later in the project as well. On George Eliot, we were responsible for all of the FF&E, small power, that sort of thing. What we did was effectively model all of those elements at quite a high level. They're not very detailed models. It's quite basic representations. But what we've done with each of those models is embed the procurement code that the contractor's using to buy those elements. So what we were able to do with the stakeholders is make changes to their particular classrooms or particular parts of the building. And then when we synchronize our model with the procurement software, we were able to update and make sure that we're not buying too many chairs, not buying too many sockets. And the building was completed at Christmas, and we've had no complaints, which is so it worked. So in terms of the design team, this is where we think there's one of the biggest cultural changes in the process. What we're finding now is design team meetings are focused around the model. So over the last few years, we'd found that design team meetings have become really meetings where people came along and said what they had done in the previous couple of weeks and what they were going to do in the next few weeks. And they were looking at compliance reports and percentage completeness reports, that sort of thing. What's happening now is effectively things are getting resolved in design team meetings in real time rather than being taken away. So everyday problems like CDM issues to do with access to the roof, instead of someone going away and resolving it, coming back a few weeks later, it's getting resolved in the meeting because we're able to just walk the route to the roof, make the change in real time on the model, and just move on. So that's we think that what that's doing is actually making the team much more collaborative. Everyone's got a stake in the model. It's becoming far less adversarial because everyone's involved, everyone's sharing it. So what we found now in the office is that we've really pushed this idea of the projector screens. We've now got 3 projector screens in the office. Because effectively that's the view into the project. So in the way that when we used to have drawings around the office, you could see what was going on. Now the projector screen is the way to see things. We're actually printing very little in the office at all. We've got no plan chests, no drawing hangers anymore. It's becoming much more digital, and obviously we're finding that we're sharing information over the internet as well. So I'm sure this is something many people are familiar with seeing, but effectively this is the project at a particular stage, which is showing the federated model of the different components. And the key thing that we have to communicate to some people is that this isn't a CGI. Where effectively what we're looking at here is the construction information. And what we're able to do in the design team meeting is walk the building with the stakeholders or with the design team. And at any point, we can click on any component and get all of that data that we've shown previously out of the model. We can take dimensions off this. It's a really useful tool. Increasingly, we're encouraging the contractor to have this on site, and our team are now taking it to site on iPads. And what we're looking at the moment, and we're just trialling at the moment, is starting to share it over the cloud. And it's actually these tools where we're finding that we're resolving most of the issues. So there are other tools such as clash detection, which I'll go on to, but for the size of project that we're working on, we're resolving most of the problems just by looking at the information in a much more useful way using the 3D model. So clash detection, which I'm sure is something that a lot of people are familiar with, is effectively the software can go out and look for problems within the model. What it's relying on is the fact that no two objects can occupy the same virtual space. So here we've got a duct that isn't quite making it through a concrete wall, and we're able to, the software will find that for us, we're able to then mark that up, produce a visual representation of it. That can become an action for the next design team meeting, to resolve that. And similarly with the, going back to the projector screens, two of those are actually interactive. So we're doing a lot of this on the whiteboard, which is getting people much more involved with the model. And so we're finding now that rather than sort of sitting passively in a design team meeting, people are almost fighting to get up there and mark up the drawings. And again, time's just another attribute that we can attach to the model. And here, this is just a very simple sequence, construction sequence. What we've got is the Primavera program running at the bottom, and then we're just running a sort of a demo of the construction sequence of the project. Very useful for the contractor. As architects, we're finding this is useful for describing sequencing, particularly in existing buildings. So for some of our school projects, there can be up to 19 moves to decant and move people around a live school while we're doing the work. And again, we're being asked by contractors to describe the logistics and their site sequencing, again, three-dimensionally, and they're finding this is really useful when they're trying to pitch for work with a client to explain how they'd actually go about sequencing the construction, where they're going to put health and safety, welfare, that sort of stuff on site, site storage, that sort of thing. We've had an interesting experience with quantity takeoff. We've been through two processes, one with a major contractor and one with a large quantity surveying firm. What we did with the major contractor is effectively, it's again on George Eliot School, we had a full manual traditional takeoff for the project. And what we did was a digital takeoff at this, and compared the two. And it was very interesting what we were finding. Effectively, 50% of it was absolutely the same. 50% of it was wildly different. And so we then went right the way through the project and worked out what the reasons for the variances were all the way through. Broadly speaking, half of the variances came down to the fact that the model hadn't been built with a view to taking quantity off. So it was effectively irregularities in the way that the model had been built. So it does demonstrate that we're going to have to think very carefully and build the models very carefully. And 50% of the variance was really idiosyncrasies in the way that people measure a quantity in a model. So effectively, different techniques that people use, different shortcuts people use to measure. The process with the quantity surveying firm was much more satisfactory, and effectively what they were doing was using tools that they could analyse the BIM model but still overlay their knowledge and use their tricks of the trade, and that worked much better. We've been we're at an early stage. We've done a couple of projects where we've completed the project and then embedded facilities management information into it. We've done it on 2 very small projects, really to try and demonstrate to our client that it's a good idea to try and encourage them to pursue it. But we're now about to look at the very large project that we were talking about earlier, the Adult Education Centre, looking at going back into that model and embedding, doing a much more thorough job at embedding much more information into it. But here, effectively, we've used the Navisworks model to put further information in it. And similarly, again, on this is a little student housing scheme. We did the same thing, but it included all the furniture and all the kitchens, that sort of thing. So in terms of the stakeholders, what we're finding there is that we're managing expectations far better than we used to. So clearly, from an early stage, the clients and the stakeholders can see exactly what it is that they're going to get. So even though this is a very high-level model, and it's not really there for selling techniques, it's very useful for a teacher to see exactly what it is they're going to get in their classroom and have an opinion about it. It's not going to be a surprise when they walk in there, sort of 3 weeks before it's completed. That's managing expectations and moving the project forward. This is, again, we've been using some third-party software. So again, this is the construction model just dropped straight into another software where we're able to walk around the project with a client. And this is actually a real-time renderer. So we're able to change colours and textures and finishes within the model. So what we're doing, in effect, is getting a bit of buy-in from the end users, because we're able to present them with a palette of options, and they can make those decisions and see what they're going to look like, before it's built. So previously we would have gone along with lots of 2D drawings, marked them up, and people would forget what it is that they asked for. So it's we're finding that very useful. And again, the fact that the 3D models it means that we're able to get very quick renders out of it. This is a 2-minute exercise, which is not going to win any awards, but it's very useful for signing off planning conditions, or again stakeholder engagement and people understanding what a change might look like. And again, because the model exists, when we're doing high quality renders for sales purposes or for a planning application, we're not paying for a specialist. We're only paying for a specialist to do the render and to do the final finish of the image, rather than build the model in the first place. So again, that's saving our client quite big amounts of money at those stages. So what's that? What's all this meant to us in terms of costs and in terms of benefits? What we did a year or so ago was effectively go back over the process of adoption since 2008 and analyse our costs and the benefits that we believe that we received. And as architects, different consultants in different parts of the industry will have different costs, but as architects we found that we've effectively spent about £10,000 a seat on this, which seems like quite an investment. That actually translates exactly to €10,000 today as well. But when you look at that investment over a 4-year period and break it down into training, software and hardware, you see that actually the hardware is hardly important. The software is quite a big investment, but the biggest investment is actually the training. And again, that's a really positive. I think that's actually quite a positive message, because the training is it incentivises the staff, and it's been a very positive thing for the practice. And it's actually been a big contributor to us getting a higher level of investors in people award. We've effectively been spending £30,000 a year for 4 years, which seems like a terrifying amount for a small practice. But then when you actually look at it in terms of technical staff costs and fee income, you can see that it's actually quite a small band. And our argument has been, why wouldn't you invest that money to get an efficiency, and also to retain and to motivate really good members of staff? But then the really positive side of it was when we started to actually look at our technical staff costs, which is the blue line. The green line is showing the extra over that we've been spending on the training and on the investment in the software. And then the red line is our fee income over the last 4 years. And you can see that while we were, for the first 18 months, 2 years, while we were still learning to use the software, and we were still developing our process, that stayed very parallel. But once we got more efficient, we got used to it. We feel as though we've had very real advantages from it. Now we're absolutely aware that this could be a consequence of a small practice growing and doing bigger jobs, and therefore potentially making more margin on those jobs. So we're not saying that this is absolutely what will happen, but we feel that the fact that the office has grown is probably due to its use of BIM as well. So in a way, BIM tools have been the driver, we think, for that increase in margin. And similarly, looking at the size of projects that we've been doing over a 4-year period, they've grown substantially. So in 2008, our biggest project was a £2.5 million private house extension. It was a private swimming pool, and we're actually just starting on. Well, we're a couple of months on site on a £25 million mixed-use development in East London. So over a 4-year period, that's represented quite a big change in how the office has been working and how it's being perceived. So for us, really, we think that you can tell that we're quite keen on BIM, but we believe it's given the advantage that it's given us is accurate, coordinated information. We've been avoiding costs through early problem detection, through the fact that the software is so interactive and so transparent. And we're getting very real efficiencies in production information in a very tough environment. We're like everyone, we're working in with very suppressed fees at the moment. And that's it. Thank you very much.